Beginning at Tesla's 2025 Annual Shareholder Meeting, the company formally presented the newest evolution of its long-anticipated electric semi, marking a decisive shift from the limited prototype era into a phase approaching true mass production. Elon Musk reiterated that full-scale manufacturing of the FSD-equipped semi will begin early next year, following the initial internal rollout plan for 2026. Although Tesla has previously placed small pilot fleets with partners like PepsiCo and Frito, the company confirmed that it will become its own first commercial customer, integrating the semi into its logistics network to refine performance, analyze operational reliability, and streamline supply chain efficiency before wider commercial distribution. Dan Priestley, head of the semi program, emphasized that the transition away from fuel-powered trucking within Tesla's own logistics will serve as the model for future customers once production ramps. The dedicated semi-factory in Reno, Nevada, spanning over 1.7 million square feet, has reached major construction milestones, with heavy manufacturing equipment now being installed, signaling Tesla's readiness for sustained volume output. Only about 250 semis have been built since the truck's 2017 reveal, meaning every unit on the road has effectively been a prototype. The refreshed design unveiled at the meeting marks the first version engineered for high-volume production. The redesign is sweeping. The front end adopts a more streamlined, Cybertruck-influenced aesthetic, replacing the earlier stacked headlights with a full-width LED bar, while the reshaped bumper and aero channel contours reduce drag. New camera placements ahead of the door support Tesla's increasing tilt toward autonomy. Beyond visuals, the semi's technical foundations have been meaningfully reworked. Tesla reports a drag coefficient reduction that boosts efficiency and supports its claim of roughly 1.53 kilowatt-hours per mile, maintaining a range near 500 miles with an estimated 850 kilowatt-hour battery pack. The updated drivetrain preserves the instant torque characteristics expected from an electric Class 8 truck, allowing rapid acceleration even at an 80,000-pound gross weight. Charging remains a standout feature, with megawatt-class capability, restoring about 70% of the range in half an hour, drastically reducing downtime for fleet operators. Payload capacity has also increased thanks to refined structural design and likely integration of next-generation 4,680 cells, which raise energy density while trimming vehicle mass. These improvements position the semi as an economically attractive alternative to diesel, especially when considering lifetime fuel and maintenance savings. Tesla also highlighted the truck's readiness for autonomy. Additional sensors and FSD-ready hardware are included, with Tesla indicating that future OTA updates could gradually unlock more advanced automated driving functions, critical for an industry contending with driver shortages and demanding long-haul schedules. Inside the cabin, Tesla incorporated a more aerodynamic windshield, a driver-centric central seating position, and dual displays that mirror the interface style of its passenger vehicles. The quieter, more ergonomic interior aims to attract a new wave of operators accustomed to modern EV interfaces rather than traditional diesel truck cabins. Tesla has also refined manufacturing strategies by sharing parts with vehicles like the Cybertruck and Model X, streamlining assembly and reducing costs. Analysts estimate that the second-generation semi may be priced between $160,000 and $190,000, depending on configuration, a figure still highly competitive when factoring long-term operating savings. Earlier reservation programs required staged deposits, though Tesla has since closed public reservations, redirecting procurement through its commercial vehicle division. Major companies such as Walmart, UPS, DHL, Cisco, J.B. Hunt, and Anheuser-Busch remain in line for early units after Tesla's internal fleet deployment validates real-world performance. Tesla's production timeline indicates limited builds by late 2025, expanding into meaningful volume through the second half of 2026. Energy consumption at roughly 1.7 kilowatt-hours per mile represents a dramatic efficiency lead over diesel, which typically burn a gallon every 6.5 miles. At current energy prices, this yields nearly 45% cost reduction per mile, translating into annual savings around $24,000 for fleets traveling 100,000 miles a year. Over a decade, those savings can nearly equal the truck's purchase cost. Maintenance reductions are similarly substantial since electric drivetrains eliminate components prone to wear in diesel systems. Tesla underscores that fleets preparing for 2026 deliveries should coordinate early regarding charging infrastructure, particularly megacharger installation, to ensure operational readiness. With refined aerodynamics, increased payload capacity, faster charging, stronger manufacturing economics, and built-in autonomy hardware, the updated Semi represents Tesla's strongest push yet to transform heavy-duty freight. Continuing from this momentum, Tesla's broader objective for the Semi program is to reshape the foundations of heavy-duty transport by merging lower energy consumption with scalable manufacturing efficiency. As the Reno facility transitions from equipment installation to structured pilot runs, Tesla engineers are finalizing assembly line sequences that draw heavily on lessons learned from both the Cybertruck and the Model Y production systems. This approach ensures that the Semi Gen 2 will roll off the line with greater consistency and lower production complexity than early prototypes, which require more manual intervention and lack standardized parts. The updated structure of the cabin roofline and the reduced windshield profile were not only designed for better aerodynamics, but also to simplify stamping and alignment, cutting both material usage and assembly time. Tesla's internal logistics deployment beginning in 2026 will serve as a proving ground for the drivetrain's durability, thermal management systems, and megawatt charging compatibility under continuous real-world stress. Early insights from these fleet operations will shape software calibration for torque distribution, reg and braking smoothness, and energy efficiency mapping across varied terrains. Tesla also intends to evaluate how the Semi integrates with its warehouse-to-factory supply routing, using the FSD hardware suite to test supervised autonomous navigation along predictable highway corridors. These supervised modes will lay the groundwork for future autonomy updates once regulatory approval matures. Meanwhile, suppliers have already begun scaling component production to match Tesla's 2026 volume targets, especially for the 4,680 cell variants designed for large pack thermal stability. The Semi's projected cost advantage continues to attract major logistics firms despite the absence of open reservations, and industry analysts expect the shift to electric freight to accelerate once Tesla demonstrates consistent uptime and lower maintenance cycles during its internal rollout. This next phase represents Tesla's attempt to prove not only that an electric Class 8 platform is viable, but that it can outperform diesel across an entire operational life cycle.